Right, hello and welcome to this discussion that I am making here. We want to talk about econometrics. The purpose of this video is to help students who don't have a good statistical background but who certainly deserve a chance in doing econometrics. Now, as you know, the word econometrics really refers to the idea of economic measurement. In other words, we are interested in measuring the size of the effect of one variable on another variable. Now, to be able to do that, we have to deploy statistical and mathematical concepts, but generally, econometrics is more about addition, subtraction, multiplication, and division in large part. So now, there are three concepts, related concepts that you need to understand from day one. These are covariance, these are correlation, and regression. You can move from here to there, you can move from here to there, or directly from here to there. So there are several interrelationships amongst those three variables, and you need to convince yourself by the end of this course in June that you have understood those three relationships. So what is covariance? Coming from the word covary, it means that we are looking at the extent to which two economic variables tend to move together. Now, variables can move together in the positive direction, which means as one variable increases, another is also increasing, or which also means as one variable decreases, another is decreasing. In other words, there is a positive relationship. They always move in the same direction. Then there is a situation where they move in opposite directions. Your law of demand, for example, says quantity demanded and price move in opposite directions. It's covariance again. Or sometimes it is zero, which just means that they are not associated with each other. So technically, covariance measures the direction of the linear relationship between two variables. So it measures direction of association between any two variables. Correlation, on the other hand, it performs the same function as correlation, but the difference is that it measures the reliability of this direction of relationship or direction of association. Now, as you can see, these two concepts here are symmetrical, which means that we actually don't know whether this variable affects that or that variable affects this. So it doesn't really matter to us if we say metric results affect econometric performance or economic metric performance affects metric results. So if we don't know which one is causing which, we say the relationship is symmetrical. But in economic theory, we actually know which variables affect which ones. And now when you are in the domain of regression, you are now measuring. This is where econometrics comes in. You are now measuring the size of the effect of one variable on another. What's the size of the effect of price on quantity demanded? The size of that effect is what we are calling economic measurement, that is econometrics. It comes from that idea. So here now we have an asymmetric relationship. What do I mean by this long word? It means that now we know which variable is causing which. The variables don't have the same effect on each other. Rather, one is affecting the other and the other is not feeding back. Do you see that? So it is not quantity demanded which affects price, but it is price which affects quantity demanded. It's now an asymmetric relationship. So that differentiates regression from correlation and covariance. But today I want to talk about covariance. We start from a hypothetical example. Now let's say you are studying the labor market. You want to know the relationship between your wage and your education, which we shall call X to save space. If you never went to school, your education is 0, or if you went up to grade 7, or if you went up to grade 11, or if you went up to grade 12, or if you went up to grade 15, let's just call that grade 15, meaning your undergrad, or grade 16, which is your honors, or grade 18, which is your master's. We want to see how your wage changes. Now I have an example here. I'll just put the values that I have on paper. 3,000, 10,000, 18,500. I left something out actually. I jumped some number somewhere. Okay, so there is 8,000, then there is 10,000, then there is 18,500, there is 22,500, and there is 29,000. We can look at the sum. I'll just use this Greek symbol which means to add. Then I want the mean from that. Those are the two things I need. Now, so here what we're saying is if you never went to school, this is what we expect you to earn per month in the labor market. As your years of education increase, your wage rate tends to increase per month. So in this case, we are saying the variables are positively correlated. Their covariance is positive. They are positively associated. They tend to move in the same direction. The higher the level of education, the higher the wage rate. Now, but these words high and low statistically can only be determined if we have a reference point. And the reference point is the mean. We are actually measuring the distance of any observation from its mean. Okay? So the distance of any observation from its mean, which is here, is, for example, if you're talking about wage, that is y, the wage we are observing, minus the mean for the whole group. This is called a deviation from the mean. And this deviation from the mean, if it is positive, tells us that this observation we have here is a high value observation. That's where the word high comes from. It means it is bigger than the mean. If this number here is less than 0, it means that this observation is smaller than the mean. So we call it a low value. Now, if this number is equal to 0, then it just means this observation is exactly where the average or the mean is. Okay? So we do the same for x. We also find x minus x bar, and we will find that it might be greater than 0, which is a high value, less than 0, which is a low value, equal to 0, which means it's equal to its mean. But for us to talk about covariance, we are actually looking at the product of the deviation of y from its mean and the deviation of x from its mean. The deviation of wages from their mean and the deviation of education from its mean. So the product of these two deviations tell us if variables are moving together or not. Okay, so that's what we essentially want to do. So for us to be able to do that, we need to find y minus y bar. Then we need to find x minus x bar. Then once that is done, then we can find y minus y bar times x minus x bar. Now this tells us whether they are moving together or not. Now, to save time, I've already calculated these ahead of you. Now, the sum here is 91,500. The mean is 13,071.4. The sum here is 79. The mean is 11.3. Okay? So here we have minus 12,571.4. We have minus 10,071.4. We have minus 5,071.4. We have minus 3,071.4. We have 5,428.6. We have 9,428.6. We have 15,928.6. Now, if you add these numbers, if you add all these numbers here, you should get 0. Now, let's do the same for x. You have minus 11.3, minus 4.3, minus 0.3, 0.7, 3.7, 4.7, 6.7. If you add these numbers, you should get 0. Now, so notice here, this is your y versus its mean, which is this big. Hence, we have y minus y bar being a small number. So we say it's a low value. Now, notice also for x, which is 0, and its mean is 11, the number is also negative, which means it's a low value, it's a low level of education. Now, if you multiply the two because they are both negative, you get a positive number. Now, the answers you get are 158,040,098, or 101,433,098. You will get 25,719,098. Ooh, I'm copying the wrong numbers. My goodness. Okay, I've got so many things written down. It's either the 1, 1, 02 056.82 43307.02. Then you have got 1521.42. Then you have minus, because 1 is positive, 1 is negative, 2149.98. Then you have 20085.82. Then you have 44314.42. Then you have 106,721.62. Now, if you sum those numbers, you will get 355,857.14. Now, your covariance is equal to the sum of these products of the deviations. That is, we are adding this number I have here. That is what this thing is saying. It's saying I should add all this to get that. It's the sum of y minus y bar, x minus x bar, and all that we divide it by the sample size. Our sample is 1, 2, 3, 4, 5, 6, 7. There are 7 people we interviewed in the labor market. But because we used this data to calculate one sample statistic called the mean, we must subtract 1. So now we have n minus 1 degrees of freedom. Now this number here is the numerator, which is sum of y minus y bar times x minus x bar. So it's 355,857.14. All this we divide by 7 minus 1. So what is our answer? Our answer will be 59,309.52. The number you see there is called the covariance of the wage rate and education. Now, there are several things that we can discuss about the covariance. Because you find it positive here, it actually means that the level of education tends to be positively associated with a high wage, to be positively associated with the wage rate in the sample. That's what it essentially means. But there are several properties. Now, the covariance is very sensitive to the scale of measurement. In economics, sometimes instead of me presenting these numbers as big as they are, I might present these as 3 rand in thousands, so that these zeros are not there. This becomes 0 point. This becomes 8 only. This becomes 10 only. This becomes 18.5. This becomes 22.5. This becomes 29 only. You see that? And this becomes 91.5. And this will become 13.07. Now, changing the scale of measurement like this will change the covariance. So it is very sensitive to the scale of measurement. That's one thing about it. The other is that it is symmetrical. It doesn't matter whether I say covariance of education and wages or covariance of wages and education, you still get the same answer. And lastly, it is very sensitive also to the units of measurement. The number we got here is actually reported as rand years. That's its units of measurement. But what does that mean to say rand years? It's difficult to interpret, right? So what generally then happens is that economists or econometricians want to find a measure that is not sensitive to units of measurement and that is not sensitive to the scale of measurement, and that measure is called correlation. So that means it takes us into the study of correlation. But essentially, this is your covariance. That's all you need to know.